recording. Move to the first slide. And here, well, before we have a little game to play today to make things a little interesting. And I'm always interested in knowing what you guys think. So there are how much people on the screen here? 10 characters, right? I won't read through all. Have Jinjin, Felix, Tommy, and so forth. What's going to happen? Each of these characters are going to come to a tragic end. They're going to have something, they're going to die, to put it in a polite way, right? Only one character is going to be alive at the end of class. I want everyone to choose one character and let me know on the chat. Who do you think will be alive at the end of class? Don't worry, their deaths won't be too, it's going to be more comical than tragic. Okay, so let me know on the chat, guys, right? Who do you think is going to be alive at the end of class? Go. So we're going to first start off with the basic parts of a circle. Yeah, like I said, I know this is really basic stuff, but I have to make sure, and it's our first class, so I can take my time and move a little bit slow. So on the screen, you see a circle. The distance around the circle, the distance from the center of the circle to the circumference. The circumference is the piece that goes around the circle, which is what makes the circle. So from the center of the circle to the circumference, you call that the radius. That's the radius there. The diameter is a little bit different. The diameter goes from one side of the circumference through the center back to the other side, but it has to go through the center. And as you all probably remember from primary school, the diameter, not only does it go through the center, but the radius also starts at the center. But more importantly, I don't know if you all remember this, the diameter is twice the length of the radius. So for example, if your radius from the center to the circumference was 12 centimeters, I'm just saying if the diameter is always twice the length of the radius, which will bring us to what? 12 multiplied by 2 is 24 centimeters. All right, some easy stuff there. Another thing you're going to be bouncing up today, other than a radius and a diameter, is something called the chord. Here's the difference between a diameter and a chord. Both the diameter and the chord start on one side of the circle, right, the circumference, and it makes it to the other side. But a chord, generally when they say a chord, right, a chord does not go through the center. You see how the diameter starts on this side, goes through the center, and then makes it to the other side? Well, that's a diameter. A chord will always be shorter. It starts on one side and it goes to the other side, but it doesn't actually what? Go through the center. So over here we have radius, diameter, and chord definitions for the CSEC exam. However, I want to, talk about this thing called an arc. The full distance around a circle. You see this white line? You call the full distance the circumference. An arc is only piece of the circumference. So for example, if you have an ant standing at point A, right? There. And the ant walks around the entire circle and comes back to A. Well, we call that the circumference. An arc is just piece of the circumference. So do me a favor here. If you look on the screen here, I'm just going to color piece of the circumference in red. You see that there? From A to B. If an ant walks from A to B, you notice it doesn't walk all the way around a circle. The circle, sorry. You call that an arc, A-R-C. So an arc is just piece of a circumference or piece of a circle to keep it very, very, very simple. Here's what I need for you guys to do. I know this is basic. I want you to draw this diagram and take down the definitions. Even if you know it, right? I still want you to take it down. And don't worry, but when I'm doing the questions today, I'm going to remind you what is a radius. I'm going to keep reminding you that a diameter is twice the length of a radius over and over and over till it comes super annoying, right? So anyway, guys, whenever you finish taking on everything on the screen here, don't take more than 2 minutes. You'll just let me know on the chat, or you can just simply raise your hand. Let's go. Right. Do not draw anything as yet. All right. First things first, there are 7 rules we have to do for this topic. Go to a brand new page. Yes, you're going to have to waste plenty paper today. At the top of the page, write rule 1. Like I said, it's 7 rules in all. This is rule 1 we're going to be discussing, right? When you are finished writing rule 1, I want you all to draw in pencil. Don't use pen as yet, pencil. Draw a circle for me, right? Draw a circle and just wait on me, right? Right? Don't take down anything else as yet. Do you all remember how they used to draw, like when it was in primary school, how you would draw a stick man, right? You'll draw the head, you'll draw the neck, the hands, this could be the body, and then it will have what? 2 legs, okay? I think you all remember how to draw a stick man. If I were to erase this, and this, and you'll be left with the legs, today you're going to be seeing a kind of upside down V for the majority of class. You are going to pretend these are legs. I'm going to call them what? Legs. Also, remember how you would draw an eye in primary school or in biology class, for example. I know this doesn't look like an eye, but if I do this and I put this, does that look like an eye? For those who can't see that, if I put in a nose and a mouth and a head, you all see the eye now? Look at, here's a big googly eye here. And isn't the eye looking in this direction? So today, I'm going to be drawing legs and I'm going to be drawing eyes that look like this. And of course, this is the direction the eye is looking. If you have a eye like this, then the eye is looking which way? In the direction of that particular arrow. So do me a favor. You're going to be in my diagrams, you're going to be seeing things that resemble legs, and you're going to be seeing things that resemble what? Eyes, right? So let's be on the lookout for that, right? All right, so let's start off this question here. On your particular diagram, right? Here's what I want you to do. I want you to put A and I want you to put B. And then I want you to connect A to B in a different color to the rest of the circle. Let me get a different color here. Right? Right? You get to choose where A and B is, right? But just approximate it to the same positions here. This here is point A, and this here is point B. Right? You can probably use a red ink pen or a blue ink pen. Does everyone agree that that yellow line is an arc? Are we all in agreement with that? You can just raise your hands, right? Are we all in agreement from A to B is only part of the circumference, better known as an arc? Now, here's what you're going to do. Look at my diagram. I'm going to start at point A. from point A, I'm going to draw a line from A at the beginning of the arc, and it's going to hit the circumference. Look at that yellow line. Look at that. It starts at A, and I draw it to hit the circumference. I want everyone to draw that line for me. It doesn't matter where it hits the circumference. It could hit anywhere on the circumference, but make it look like mine, somewhere on top here. Everyone drawing that for me. At the beginning of the arc, we draw a line to hit a point on the circumference. And here's what's going to happen. When the line hits the circumference, pretend you shoot like a bullet. So you shoot it. And then it's going to hit the circumference and bounce back to the end of the arc, which is point B. Look at it there. So what we have effectively done is that we have drawn a line from point A to hit a point on the circumference. It must touch the circumference, and it bounces back to the end of the arc. So everyone draw that in their books. Now, I think we all agree that there must be an angle here. Like if we were to use a protractor, we would get an angle here. If we were to measure the angle in between the legs, you'll realize this is like a pair of legs here, right? One leg, the other leg. There must be an angle in between the legs there. Now, I don't know what the angle is. I don't have a protractor on me. It might be 30 degrees. It might be 42 degrees. It might be 53 degrees. I don't know the actual angle. But let's just pretend that the angle was 33 degrees. Let's just pretend. So everyone writing 33 degrees there for me. Right? We just pretending that we used our protractor and we measure the angle. Now, here's what we're going to do now. You have seen nothing amazing so far. This is pretty boring so far. But circles are magical. Whenever you place lines in certain patterns, cool things begin to happen. So here's what we're going to do now. I want you all to go back to the beginning of the arc. Remember point A, he's the beginning of the arc. We are going to draw another straight line. The line is going to start at A, but look at what happens now. It starts at A, but the red line, it goes and hits a different point on the circumference. So it starts at A, it's just the line hits a different point on the circumference. So everyone do that for me. Use a different color ink. If you have a red ink or a blue ink, some people have green inks and whatnot, right? And when it hits the circumference, it's going to bounce back to point B. Right? All right. So everyone, you notice this is another pair of legs. The first pair of legs is yellow. The next pair of legs is what? Reddish, right? Even though both of them touch the circumference at different points, do we all agree that both legs start at A and both legs end at B? Whenever that happens in maths, you see this angle between your red legs, he will also be 33 degrees. It's like magic. So if he was 42 degrees, the other one would have also been 42. Even though both of them touch in different points on the circumference, the angle, for some strange reason, ends up being the same. In fact, any pair of legs that start at A and end at B, once it touches the circumference at any point, its angle will always be equal to these two. Let me show you what I mean. Let's take another pair of legs. Look at this blue pair of legs here. It's starting at A. It hits the circumference at a completely different point. And now it's going to bounce back to B. Look at it. It started at A. It hit the circumference at a completely different point, but it bounces back to B. Guess what? If the examiner were to ask you, hey, what's the size of this angle? The answer would also be 33 degrees. It's magic. However, there's one more thing you have to consider. Remember I told you about the eyes? Remember how you would draw an eye? Like if you see this here, I know you already don't see any eyes as yet. But if I do this, if I put this here, if I put this here, and I put this here, and it looks like you have three eyes here, a blue eye, a yellow eye, and a red eye. Tell me something. Are all the eyes looking in the same general direction? Are all of them looking downwards at the same point? You notice all of them looking at the same point. They are looking in the same direction. The angles are only equal, right? If they both start at A, end at B, touch the circumference, and also they must be looking in the same direction. If the eyes are not looking in the same direction, the rule doesn't apply. Hence this rule here. So in the exam, you have to be able to write out this rule. You have to write a paragraph describing this rule. And this is what you need to write for the examiner. Rule 1, you can't write rule 1. You have to write out what rule 1 is. Angles standing on the same arc. You notice all of them standing on the same arc, that arc being AB, and touching the circumference, yes, 1, 2, 3, have the same size. The part about the eyes looking in the same direction, you don't actually need to write that in the exam. That's just for you to know if the rule works. I want you to take down everything on the screen, every single thing, including the rule itself. I know some of you are scratching your heads. Oh God, it's like, it didn't make 100% sense. But we will try some examples of each rule as we go along. All right? Let me know when you guys are finished. So what about if the circle was upside down, right? You know, sometimes somebody might take a copybook and turn it upside down. Do you think if you put the copybook upside down, do you think that will change the rule? No. How right? Right. So 1 second. Right. So let's draw another circle. And I want you all to draw another arc here, but we want to draw the arc to the top this time, right? One second, guys. I just want to get something in, right? Right. Right. I just want to point out one thing in class, right? I know some of you all are complaining that you can't talk to the other students, right? I have it like that for a reason, right? You all can only contact me or send messages to me for safety reasons also. Also, we're not really here to talk to each other, right? You're just here to talk to me, right? So I just wanted to clear that up. So here's what I want you all to do. Draw a circle, right? And I want you all to draw an arc to the top of the circle. Notice the arc is in a different position, which is what some people were confused about. They were asking, hey, if the arc was somewhere else in the question, would rule 1 still apply? So here's what we're going to do now. The beginning of this arc is point A, and the end of the arc is B. Rule 1 states that if a leg starts at the beginning of the arc, if it hits the circumference and bounces back to the end of the arc, well, then it's entitled to be called rule 1. So let's do that. Starting at A, the blue line hits the circumference. And guess what? It's going to bounce back to the end of the arc, point B. Everyone do that for me. At point A, the beginning of the arc, let the line hit the circumference and let it bounce back to the end of the arc, which is point B. Now, that's a pair of legs. It's just the legs are upside down. It's like Spider-Man walking on the ceiling, right? I think everybody will agree that if we take our protractor and we measure this angle, we will get an angle. Once again, I don't know the actual value of the angle, but let's just pretend we use our protractor. And when we use our protractor, we get 11 degrees. So everyone put in 11 degrees. Let's draw another pair of legs. It's going to start at A and it's going to finish at B, but it's going to hit the circumference at a different point. Look at it now. It's orange, A, hits the circumference and bounces back to B. It starts at A, it hits the circumference at a different point and bounces back to B. I guarantee you that if you were to use a protractor and measure this orange angle, you will get 11 degrees. In fact, you're not even supposed to use your protractor because this falls under rule 1. So without physically measuring the orange angle with a protractor, you should have predicted the answer would have been 11 degrees also. Let's try another one. Oh, sorry. Only doing 2, but some people are asking like for a third one, right? If I had an angle starting at, sorry, a leg starting at A, and it hits the circumference, and it bounces back to B, this green angle would also be 11 degrees. Now, for it to really be rule 1, all 3 eyes, because I have 3 angles here, supposed to be looking in the same direction. Quick question. Is the green, blue, and orange eyes, are all of them looking in the same direction? Yes or no? Because we know that this all of them starting at A, they're finishing at B, and they're touching what? The circumference. But just to be 100% sure, are all 3 eyes looking in the same direction? The answer is yes, right? Because look at it, if I draw an eye here, if I draw an eye, like the eye, let's call it the iris, you notice this eye looking this way, this eye looking this way, all of them looking at a sort of upwards direction, right? And guys, I don't know how big your notebooks are, right? But if 2 circles could fit on 1 page, do so. But if you're using a copybook, you might have to use what? A separate page for each diagram. So this is rule 1, just with the arc on top now, rather than the arc being underneath. All right, so everyone draw this for me. You already have the rules here already. It's just to draw the diagram, and you're taking down this note. This is rule 1 from an upside down perspective. So at the beginning of class, you had to choose a character. We're going to meet our first death at the moment. Let's see. So let's see who's the first to meet their maker, right? Out of the 10 people here, the first to go is, we're sorry to announce the death of Chops Le Mouton's. So for anyone who chose Chops, you're out of the game. Chops, a dedicated vegan, was found bearing multiple carrot stab wounds. Police suspect Chops was assassinated by a prominent gangster called Lil Quack after an illegal vegetable deal went sour. All right, so guys, Chops is out of the game. Who's out of the game? Let me know in the chat. Quite a few people chose Chops. right? I'm sorry to see you lose, but, you know, probably better luck next time. All right, do me a favor. I want you all to draw 2 blank circles. One with an arc at the bottom here, and one with an arc AB to the top. Also, I want you to put a dot by the center of the circle and call it point O. In maths, the center of the circle, there is always name it O, in the majority of the cases, right? So do me that favor, right? Draw 2 blank circles. For one of them, the arc AB goes underneath, and for the other one, the arc AB goes on top. And don't forget to put a dot by the center of the circle, and this is rule 2. So make sure and write rule 2 to the top of the paper, of your paper. In fact, rule 2 is going to start off just like rule 1. And you're going to be saying, wait now, isn't this the same rule? But there's going to be a subtle difference. So let's start off. We're going to draw a line from point A at the beginning of the arc to hit the circumference and bounce back to point B, the end of the arc. Everyone do that for me. This here is your arc, right? It starts at point A. It hits the circumference as normal, just like in rule 1, and it bounces back to the end of the arc, point B. Make sure it touches the circumference. Huh? It has to bounce on the circumference. Right. Now, if we use our protractor, we're obviously going to get an angle here. Now, I don't know the size of the angle. Let's just pretend that if we use our protractor, we will get what? 33 degrees. So everyone just put in 33 degrees, our make-believe value. Now, here's how rule 2 differs from rule 1. If it was rule 1, right, then the other arc would have started at point A. Again, it would have hit the circumference and bounced back to point B. That is if it was rule 1. But this is not rule 1. So here's the difference, right? Oops, sorry about it. So here's the difference between this rule and rule 1. When it's time to draw the second pair of legs, the second pair of legs will start at point A, but instead of hitting the circumference, it will hit the center of the circle. Remember that dot that I asked you to place at the center of the circle? It will hit the center of the circle and bounce back to point B. So it will look something like this. You notice the red line starts at A, it hits the center and bounces back at point B. So the second pair of legs doesn't actually touch the circumference. It makes contact with the center of the circle. So everyone do that for me, drawing the red pair of legs. Right? And of course, there must be an angle over here. Quick question. Which angle looks bigger? The yellow one or the new red one? I'll give, in rule 1, they will have been the same size. But by just looking at it, which one looks larger? The one at the circumference, the yellow one, or the one at the center, the red one? Which one looks bigger? And the red one looks bigger, right? Just by looking at it by eye. Well, you can't watch with anything else on any eye, right? But here's the cool thing. The one at the center, there's always be twice as large. I mean, always. So if the one at the circumference is 33, the one at the center, by magic, it would be 66. Because 33 multiplied by 2 is 66. Right? So for it to be rule 2, one has to be, both legs start at A and finish at B. Both legs are standing on the same arc. And for it to be rule 2, one has to be touching the circumference and one has to be touching the center. The one at the center is the larger one. It will always be twice as large. But here's the thing. For the rule to work, if you put eye here and an eye here, both eyes have to be looking the same direction. You notice both of them looking downwards. If the eyes are not looking the same general direction, like if one looking down, the other one had to be looking downish. If one looking up, the other one have to be looking what? Uppish, right? So that's rule 2. I'm gonna put it in words for you just now, don't worry. But what would happen if the rule 2 is upside down now? So just give me a few seconds just to make my diagram look a little bit better here. In the second diagram, this time the arc is on top. It is not underneath, but that's okay. Let's do rule 2 for an upside down arc. You all notice that the green line here, it starts at point B, it hits the circumference and bounces back to A. So this green pair of legs, it's starting at A and finishing at B. I think everyone agrees that there must be an angle here. There must be an angle. Let's say the angle is 42 degrees. I'm just saying, if it was 42 degrees. Then, if you have another pair of legs starting at point A and finishing at point B, look at this. This one is starting at point A, but he is going towards the center. And then he will do what? Bounce to B. So one is going to the circumference and one is going to the center, but both of them starting at A and finishing at B. Anybody wants to tell me what's the size of this angle here now? Let's take a wild guess. What would be the size of the blue angle, the one at the center at point O, which is called the center? Let's take a wild guess. It would be 84. Correct. It would be twice the size. Remember, the one at the center, this always be twice the size of the one at the circumference. So in case you didn't realize, 42 multiplied by 2 is 84. And if you look at it, if you convert this to an eye and you convert this to an eye, this creepy looking eye is looking upwards and this creepy green eye is also looking upwards. Both eyes are looking in the same general direction. So that is rule 2 also. Let me know when you're finished with everything on the screen there, right? It shouldn't take you too long because you're supposed to be drawing with me. Oh, by the way, sorry. Here's the wording of rule 2. Everyone take down the official words of rule 2. I'll read it back. If two angles stand on the same chord, well, I want to change this to arc, right? So I'm going to change this to arc, A-R-C. Or, sorry guys, I see some textbooks will, instead of saying it's standing on the same arc, they will say standing on the same chord. It's the same basic thing, because if you were to draw a line from here to here, this here is a chord. It looks like it's standing on the chord. So don't let that bug you. If two angles stand on the same chord or arc, the angle at the center, that's this guy here, is twice that of the circumference one. We saw that just now. When you finish taking down the paragraph for rule 2, just raise your hand and we will move on. Right? And of course, the eyes must be looking in the same direction, right? So you can put in that note as well, right? The eyes must be looking in the same direction, just like rule 1, for it to be applicable. Right. So I want to show you the trick question when it comes to rule 2. I want everyone to draw back a blank circle here, and I want you to draw an arc again. Seems like you're drawing the same thing over and over. Right? Let's do that for me. And label the beginning of the arc A and the end of the arc B. In case. If I have two lines, like a pink line, and then I have a yellow line. If one line is on top of the other line, and it just looks like it's only one line, I think that's obvious, right? If something lies on top of something else, you don't see the piece behind, right? Because the view is being what? Blocked. You're going to see that happening today. Let's look at this scenario here. I want you all to tell me if this is rule 1. Sorry, I want you all to tell me if this is rule 2. Yes or no? Is this rule 2? Yes or no? And then I'm going to rewind it and I'm going to do it slower. Is this rule 2? Yes or no? For it to be rule 2, one have to be touching the circumference and one has to be what? Touching the center, right? But it must have two pairs of legs. One pair of legs is touching the circumference and the other pair of legs is touching the center. But in this diagram, it's kind of hard to tell if there's two pairs of legs, if there's 4 legs in this diagram. So let's rewind this and do it slower. We're going to start off here. Look at what's going to happen. At point A, you're going to draw a line from A. It's going to hit the circumference, and then it's going to bounce back to the end of the arc, which is point B. And of course, if we use our protractor, you must get an angle here. Let's just call this angle 30 degrees. Everyone draw that in for me. And you notice it went through the center. When the second leg was coming down, it went through the center of the circle. It has to go through the center. So keep an eye on that when you're drawing your diagram. Put a dot for the center of the circle and label it O. Right? Right? And we're going to draw the next pair of legs now. Now look at the next pair of legs. One of them is going to start at E, which is good. That's the red. Look at it. It started at E. It hit the center, and now it's supposed to bounce back at B. But remember, piece of the yellow leg is going through the center, right? So when the second red leg tries to go back to B, won't it overlap the yellow leg? Look at it. The red just went over the yellow. The yellow is there now. It's just behind the red, so you can't really see it. Anybody wants to tell me what's the size of this red angle? What's the size of that red angle? Because I guarantee you this is rule 2. One is touching the circumference and one is touching the center. And if you draw the eyes, both of them kind of looking in the same direction. They're looking kind of downwards, both of them looking downwards. So that's good enough. So what's the size of that red angle? Send the answer in the chat if you can. Right, the answer would be 60 degrees. The one at the center, there's always be twice the one at the circumference. So this is rule 2, where two legs kind of overlap. Right? It's real popular in the exam. Right? So take down this diagram and take down the little note to go with it. And it's still under which rule? Rule 2. Let me know when you're finished by raising your hands. So let's try a practice question here, right? Here's what I want you all to do. I'm going to try to, you don't have to take this down, right? You just do me a favor. You don't have to take this down. I just want you to reason out the answer and send it on the chat. I'm going to try to trick you as much as I can here. I want you all to figure out the size of this angle here. I'll put in a little question mark here, right? What's the size of that angle? AOC. What's the size of that angle? Send it on the chat if you can. Let me use a different color here so you can see it clear. From A to C, that's clearly an arc, right? Probably if I write in the word arc. You will notice that one of them hitting the circumference at B and bouncing back to C. But then one starting at A, it hitting the center. Remember, O is the center of the circle, and it bouncing back to C. But we have to do a small check, right? Before we could confirm this is rule 2. If we convert this to an I and this to an I, this I looking this way and this I looking this way. So both eyes are looking in the same general direction, and one touching the circumference and one touching the center. So it is rule 2. The one at the center will always be twice as large. So if he is 43, here would be 86. Right? So for those who got it wrong, I hope you see that this is actually rule 2. But here's the thing now. You really think in the exam, the whole question going to be that easy? You think that's going to be the end of the question? Here's how the examiner could try to trick you now, right? Instead of asking you for this angle, which is 86, I'm going to erase it, right? Just going to erase it slowly. And instead of asking you for that angle, he were to ask you for this angle here, the angle on the other side. You see that huge angle there? What would be the size of that blue angle? Now, I'm going to pretend that I'm a student and I don't, and I'm about to get it wrong. So I'm going to show you the wrong reasoning. So I open my exam paper. I see that the examiner asked me to find this blue angle. So I say, hey, this looking something like rule 2, you know? So tell me something about rule 2. In rule 2, one angle supposed to touch the center, the circumference, and one angle supposed to touch the center. And both legs must be on the same arc. So I'm going to be like, hey, this is rule 2. The answer is 86. I'm obviously going to get that wrong, right? Because we know the 86 is on the other side. But why am I getting it wrong? Well, let's draw an eye here, right? Let's draw an eye. If I were to make this an eye, right? Isn't this eye looking the complete opposite direction? And the 43 is looking to the right of the screen, and the blue one kind of looking to the other side of the screen. For it to really be rule 2, it's not just about one touching the circumference and one touching the center. No? The eyes make a big difference, right? If the eyes are not looking in the same direction, then it is not rule 2. So how do we get this angle? Well, remember earlier, we reasoned out that this angle here, right, was 86. From primary school, a full circle is how much degrees? Do you all remember from primary school, from SDA? A full circle is how much degrees? 360 degrees. Remember that? If you turn around in a circle, you make 360. So you'll realize the pink angle combined with the blue angle is a full circle. You'll realize that? So if you could reason out this side is 86 using rule 2, then the blue angle would be how much? The blue angle would be 360 minus 86 degrees. how much would that be? You need a calculator for that. Because when you kind of when you kind of put your eyes around like this, you'll get a full circle. So if the front part using rule 2 is 86, then the part behind would be 360 minus 86, which is 274 degrees. Don't get me wrong, we still use rule 2 here, right? But using rule 2 alone wasn't the entire solution of the question. We just use rule 2, and then we use a little bit of common sense afterwards to figure out the blue angle was 274. And that is how the questions will come in the exam. It won't be straightforward like using one rule, right? Right. Right? Like I said, you don't need to take this down. This is just a practice question, and the class is being fully recorded. If at any point in time you want to review the recording, I'll give you the link after class. Don't worry. And you can watch it back and draw it at that point. But this might be a little too complicated to draw right now in class, right? All right, so let's get ready to move on, right? Great. Let's try another question. There's no need to draw it. There's no need to draw it, right? I want you all to find angle C for me. But let me use proper colors, right? Angle C. I'm going to put a question mark here. And I want you all to find angle D, right? I'll put another question mark. Think it through, right? By the way, do these two lines go through the center of the circle? Like, is this the center of the circle where the X is? The answer is no. Not because something looks like the center of a circle means it's what? The center of the circle. In the exam, if the examiner wanted this to be the center of the circle, he's supposed to put a dot and label it point O. If he didn't put a dot and label it point O, you can't assume it's the center. You cannot assume that, okay? So do me a favor, right? See if you can find the red angle and the blue angle for me. And tell me which rule you used, right? This is actually rule 1 in disguise. So let me erase some stuff from the question. Let me erase some stuff from the question, right? And prove to you it's rule 1. But first of all, I want everyone to turn back to rule 1 and just give it a look for a few seconds, right? Great. Right. So I'm going to show you it now, right? I'm going to color code it for you guys. Let's see if I can draw it. You see this orange, like I have a blank circle here, right? So I'm going to call here point A. That's this A here. And over here is D. Right? I think you all can see that this here is definitely an arc. That's definitely an arc. So that's this here. I'm going to try my best to color code it now. Now look at this, using orange. From point A, we're going to go to point B. That's this here. Right? Just do me a favor here. I don't care about the center of the circle in this question. Right. So from point A, I go to point B. And then it's going to bounce back to point D. Remember, in rule 1, it starts at the beginning of the arc. It hits the circumference and it bounces back to the end of the arc. And it seems that the angle is what? 43, right? For it to be rule 1, we have another angle starting at point A. It's going to hit the circumference, that's this here, and then bounce back to D. Oops, sorry about that. Isn't there supposed to be an angle here? You all see rule 1 now? Look at it. Both pair of legs are standing on the same arc, and this eye is looking downwards, and this eye is also looking downwards. Both eyes are looking in the same direction. That means if here's 43, according to rule 1, here's also 43. So the answer for this one here, for this question mark, is 43. Everyone okay with that one? You're seeing that it is actually rule 1. So here's what? 43. Right? But we still have to find this angle underneath here, right? Now, you'll realize that if you put the arc on top now, like if I erase this, and I pretend in the arc was on, if the arc was on top here now, if that was the arc, right? Look at it from the underneath point of view now, right? 1 second. Let me erase some lines here. If the arc is on top now, you'll notice you have one pair of legs. So I'm trying to get the correct color here for you guys. One pair of legs starts here and goes over here. So that blue pair of legs starts at B and ends at C and touches the circumference. Then if I got another color, another pair of legs start at B. It hits the circumference and bounces back to the end of the arc. Sorry, it's kind of hard. I'm making some mistakes here. So it starts at B, it hits the circumference, and bounces back to the end of the arc. You notice if you convert this to an eye now, and this to an eye, both these eyes are looking in the same direction. So this is rule 1, but from an upside down perspective now, which means if here's 39, then over here is also 39. So both of them was rule 1. One was a normal rule 1, and the other one is like you rotate your book, and it's an upside down rule 1. Right? So I hope that one made some sense. That's the best. That's the best thing I could explain it at the moment. All right. Don't worry, we have plenty more practice questions. I was telling my class yesterday that sometimes you teach something and you don't understand it 100%. That is okay. Let's work with 60 to 70%. Just get some of it down right now. And as class goes on, the weeks go on, and we do more and more practice question and you revise, everything will eventually come up to 100%. All right, so let me know on the chat, right? This particular question on a scale of 0 to 100%, how much percentage you think you understand of this question? Okay, so that's kind of gauge now, right? Like next week, I can put in more examples of the same kind now, and we'll see it a second or third time, right? So let me know in the chat there. Let me know. I'm trying to check as much messages as I can. Right? A lot of people saying it's like 50 or 60%. Somebody said 100%, right? That is okay if you're not any high percentage. You'll feel bad. All right. Let's move on, right? All right. All right, so let's see who's next on the list to go here. I think we deserve a little small brain relaxer here after that. So the first person to go was Chops. Let's see who's next on the list. Sorry, we're sorry to announce the death of Susan Otis. Apparently, Susan, at the age of 89, decided to go surfing, and a shark got her. So if anybody chose Susan, if you did, you're out of the game. All right. So two people are gone, Chops and poor Susan. Let's move on. Right. So I have a question for you guys here, right? It's a little bit harder than normal, right? But you had to use a little bit of primary school knowledge to get it out, right? We using the knowledge we got today, but you had to use a little bit of primary school knowledge mixed into it. I want you all to figure out this angle here, angle B, right? I'll give you a hint. A square. If you add up all the angles in a square, remember a square has how much angles? 4 angles, right? And when you add up all the angles in a square, you just get 360 degrees. What about a quadrilateral? In fact, any 4-sided figure, when you add up all 4 angles, I don't care if it's a weird looking 4-sided figure, any 4-sided figure, or better known as a quadrilateral, when you add up all 4 angles, you always get 360 degrees. Using that and the knowledge from today's rules, I want you all to figure out the size of angle B. I'm giving you a full take 3 minutes. And I'll give you 5 minutes. I want you to draw this diagram for me. I want you to draw this question for me, the blue diagram, right? So you have 5 minutes to draw and submit an attempt. Great. So I'm not too sure if you all seen rule 2 in this. You should be able to see rule 2 because you'll realize from B to D is an arc, right? Notice B, one going to where? The center and going to the other end of the arc. And then one starting at B, it hitting the circumference and bouncing back to D. So do me a favor, first things first. What's the size of angle A using rule 2? Because that is rule 2. I think we saw it more than enough times to realize, hey, that is rule 2. And it is rule 2 because if you convert this to an I, he looking downwards, and if you convert the 126 to an I, he is also looking where? Downwards. So let me know on the chat. What's the size of angle A? Remember, the one at the center is twice as large as the one at the circumference. So A is supposed to be half of 126. The one at the center is the one that's twice as large. So if you take 126 and divide it by 2, right? A lot of people are telling me it's 63. Make sure you understand how I got the 63. I just took the 126 and divided by 2. The one at the center is twice as large. Okay? But we're far from finishing, right? Let me draw what we have so far and only extract the parts that we need. All right? By the way, remember I told you at the beginning of the question, all the angles in any 4-sided figure is 360. I'm talking about the inside angles, the angles that are inside the shape. If the angle is outside the shape, it does not add up to 360. So whenever they say all the angles in a 4-sided figure is 360, they're talking about the angles inside the shape, not outside. So this is what we know so far. And I think you all can agree. We know here's 33. That was given in the question. We just used rule 2 to figure out here is 63, because the one at the circumference is the smaller one, half as small. But do you all see a four-sided figure anywhere in this question? Look at it. 1, 2, 3, 4. That's not a triangle, eh? This is a four-sided figure. 1, 2, 3, 4. And we now said that all the angles inside a four-sided figure is 360 degrees. Quick question. Is this 126 inside or outside? Look at it. That 126 degrees, is that inside the four-sided figure? Or is that outside or inside? Isn't this outside? How about we try to reason out this angle here? Remember, I told you all, we saw this a few minutes ago. Isn't this a full circle? Like if we combine the inside and outside and we'll get a full circle. A circle is how much degrees again? 360. So if you know the outside piece is 126, then the inside piece is 360 minus 126. You think you all can calculate this inside huge angle for me? The outside part is 126. What's the inside part? Well, I kind of put the calculation there. Use a calculator. 360 minus 126. Anybody else getting 234? Just double checking it here. Yep, seems I'm correct there. Answers coming up slow. You all agree with the 260, the 234 there? 360 minus 120. You think you all could finish the question here for me? Remember, the aim of the question is to find this angle here, angle B. All four angles inside the shape. 1, 2, 3, and 4. All four angles inside any four-sided figure. I don't care if it's a weird-looking four-sided figure. It's still four sides. Figure out the missing angle here now, angle B. Add up all three angles and minus it from 360. So you're adding up the 63, the 234, and the 33. Add up all three and minus it from 360. Right? 234 plus 63 plus 33. Send your final answer for angle B. All right, next week I'm going to do back this question, but I'm going to change up the values just to see if you all remember. Right? Send the answer, send the answer. What's the final answer? Right? Anybody here getting the final answer is 30 degrees? Because when you add 234, 33, and 63, I get in 330 degrees. So if all the angles are supposed to be 360, then this angle is 360 minus 330, which is how I got the 30 degrees. It's a mixture of Rule 2 and primary school knowledge, which is how the questions will come in the exam. Okay? Right. Right.